Fronds of kelp drift in slow suspension in the shallows, rising and falling with the motion of the water. Their edges catch the light, gold and green, dissolving into one another as the current folds them together. Nothing here holds a fixed shape for long. Everything bends, everything drifts. Then a fragment breaks away. For a moment it is indistinguishable from the rest, just another piece of algae caught in motion. But the current shifts, and the fragment does not follow. It hesitates. And then, almost imperceptibly, it moves against the flow. What looked like a fragment of kelp begins to resolve into something else. A narrow head drawn out into a long, tubular snout. A body too deliberate in its symmetry. Fins, so small they vanish unless they are already in motion, flicker just enough to hold position. This is not a piece of the forest. It is a fish, the leafy sea dragon, an animal that does not avoid danger by fleeing or fighting, but by abandoning almost every signal that would reveal it as an animal at all. In these waters, survival does not belong to the fastest or the strongest. It belongs to what cannot be seen. At first glance, leafy sea dragons may give the impression that they are seahorses. It is easy to see why. Their bodies are long and armored, their fins small, their snout tubular. These similarities are not coincidence. All belong to the same family, the Syngnathidae, a group that includes seahorses, pipefishes, and sea dragons. But within that family, resemblance can be deceptive. Seahorses are all contained within a single genus, Hippocampus. And while the leafy sea dragon shares their broader ancestry, they do not sit close to them within it. To understand where it belongs, we need to look at how this family is structured. At a broad level, pipefishes are divided into two major subfamilies. The Neurophinae carry their eggs along the trunk of their body. The Syngnathidae carry them on their tail. It is a small anatomical shift, but one that defines the major split within the group. Both seahorses and sea dragons fall within the Syngnathidae. They carry their eggs on their tail. But that shared trait is where their close similarity ends. Seahorses sit within a lineage that includes the pipefishes and Hippocampus, small, often delicate animals that share aspects of their body plan. Sea dragons, by contrast, belong to a different branch entirely, the Solanathini. This lineage begins with the alligator pipefish, the only species in its genus. Found in subtropical areas of the Indian and Pacific Oceans, it is tolerant of a wide array of coastal habitats, from lagoons to estuaries to seagrass meadows to drifting algae. From there, the group moves towards the pipe horses of Solanathus, where the body plan begins to shift, tails curling, proportions changing, hinting at a form that sits somewhere between pipefish and seahorse. But they are no more related to seahorses than sea dragons are. This distinction is easy to miss. The shared features, elongated snouts, reduced fins, armored bodies, are visually striking. But these are traits of the wider family, not evidence of a particularly close relationship. What appears to be similarity at first glance is, in many cases, a reflection of shared ancestry rather than common descent. Then come the sea dragons themselves. The genus Philopteryx includes two species, the common and ruby sea dragons, animals that already bear the elongated forms and subtle ornamentation of their more famous relative. But it is more restrained, subtler, enough to break up their outline without the elaborate deception of the final genus. Phycodurus only has one species, the leafy sea dragon, Phycodurus eques. Placed here, its relationship becomes clear. It is not a seahorse that has become more elaborate. It is the most specialized member of a completely different branch. And with that context in place, the resemblance to seahorses begins to fall apart. Seahorses of the genus Hippocampus are built around stability. Their bodies are held upright in the water, heads angled downward, their movements slow and controlled. Most importantly, their tails are prehensile. They are the only known fish with this trait, an adaptation much more common in arboreal animals. Seahorses are capable of curling their tails tightly around seagrass, coral, or sponges. They do not drift, they anchor. The leafy sea dragon cannot. Its body is held horizontally, aligned with the water rather than resisting it. The tail, though flexible, cannot grasp. There is no ability to cling to the surrounding environment, no way to fix itself in place against the movement of the sea. Instead, it is carried by it. This difference in posture and anchoring reflects a deeper divide in how these animals interact with their environment. A seahorse holds position. A sea dragon becomes part of the water around it. That divergence continues in reproduction. In seahorses, the male carries the developing eggs within a sealed brood pouch, an enclosed structure that regulates salinity, protects the embryos, and provides a degree of physiological control over their development. In the leafy sea dragon, there is no such enclosure. The eggs are attached externally, fixed to a specialized brood patch beneath the tail, exposed to the surrounding water for the duration of their development. Even here, the difference is one of protection versus exposure. Taken together, these traits reveal that the resemblance between seahorses and sea dragons is only superficial. One is built to hold fast in a complex environment. The other is built to disappear within it. In the leafy sea dragon, that disappearance is taken to an extreme. At first glance, its body appears to be covered in leaf-like structures, broad, branching appendages that seem indistinguishable from the surrounding kelp. But these are not fins. They do not propel. They do not steer. They exist only to break the outline. These appendages are not precise imitations of any single species of algae. Instead, they create a level of visual noise, irregular shapes, uneven edges, and overlapping forms that disrupt recognition entirely. To an observer, there is no clear boundary between body and background. This is important because predators are not simply looking for color matches. They are looking for structure. A fish has a recognizable silhouette, a head, a body, a tail. The leafy sea dragon removes that pattern, replacing it with something fragmented and inconsistent. But this comes at a physical cost. These structures increase drag, catching the water as the animal moves. What improves concealment simultaneously reduces efficiency. The body becomes harder to propel, reinforcing the slow, drifting movement that the camouflage depends on. But shape alone is not enough. Kelp does not remain still. It sways, bends, and drifts with the motion of the water. And so the sea dragon must do the same. Its movements are slow, almost imperceptible. A small dorsal fin beats rapidly along its back, providing just enough propulsion to maintain position. Pectoral fins near the head make minute adjustments, correcting its orientation in the current. The body follows the water, not resisting it, but yielding to it, so that the motion itself becomes part of the disguise. It is not mimicking a single species of algae, it is mimicking a system, the shifting, unpredictable movements of the kelp forest as a whole. This is a form of what is often called dynamic camouflage, where concealment depends not just on appearance, but on behavior. The sea dragon must continuously match the movement of its environment. Too rigid, and it stands out. Too independent, and it becomes recognizable. In effect, the animal is not just hidden within the kelp forest, it is integrated into its motion. The distinction between organism and environment becomes blurred, not only in shape, but in time. And part of what makes this so effective is how many predators, or even humans, perceive the world. Eyes are often keyed to notice movement. Still shapes can go completely unnoticed. Take this, for example. Can you spot the sea dragon here? I promise there is one. Now, watch again, this time in motion. Movement is usually the trigger that makes animals pay attention. But in a forest that is already swaying, drifting, and flowing, movement itself can become part of the disguise. The sea dragon does not fight the water, it becomes part of it. To remain unseen, the leafy sea dragon cannot move like a typical fish. Its body is not built for flexibility. Instead of overlapping scales, it is encased in rings of bony plates, rigid, armor-like structures that protect it from predators in a way that speed cannot. Sharp spines run along the body, and when threatened, the sea dragon can curl slightly, presenting a hardened, unpalatable form. But that protection comes at a cost. The same rigidity that provides defense also limits movement. The body cannot undulate to generate thrust. The elaborate leaf-like appendages, so effective at breaking up the outline, add further resistance, catching the water and increasing drag. Speed is sacrificed for subtlety. In many fishes, Speed is the primary defense, a means of escaping predators or pursuing prey. In the leafy sea dragon, that option has been largely removed. Its body cannot generate rapid acceleration, nor sustain prolonged movement. Survival depends on avoiding detection in the first place. This shifts the balance of its entire biology. Energy is not invested in powerful musculature or rapid bursts of motion, but in maintaining position and control. Even small adjustments must be efficient, as unnecessary movement risks both exposure and wasted effort. Instead, propulsion comes from a different solution. A tiny dorsal fin along the back beats rapidly, often more than 30 times per second, generating just enough force to hold position. Near the head, small pectoral fins make constant minute adjustments, fine-tuning orientation rather than driving motion. Even buoyancy plays a role. With the aid of a swim bladder, the sea dragon can maintain a near-perfect horizontal position in the water column with minimal effort, allowing it to drift with the current and mirror the movement of the surrounding kelp. It does not push through the water, it yields to it, and that same constraint shapes how it feeds. The leafy sea dragon is an ambush predator. Its long, tubular snout generates suction, drawing in small crustaceans, mysids, and other planktonic prey whole. There is no pursuit, no sudden burst of speed. Prey must come within reach. This reliance on passive feeding means that success is tied closely to environmental conditions. Water movement must be sufficient to bring prey within range, but not so strong as to displace the animal entirely. In this way, feeding is not just a matter of anatomy, but of timing and position, of being in the right place within a constantly shifting system. Every movement must be measured. Too fast and the illusion breaks. Too slow and the opportunity passes. In becoming invisible, the sea dragon has given up the ability to chase. It survives instead by waiting, drifting, watching, and feeding only when the current delivers what it needs. Even in reproduction, the same pattern continues. Across the family Cygnathidae, one trait stands out. It is the males, not the females, that carry the developing eggs. In seahorses, this process reaches its most complex form. The eggs are transferred into a sealed brood pouch, where they are enclosed, protected, and regulated. Salinity, oxygen, and nutrients can all be controlled as the embryos develop. The leafy sea dragon does not go this far. Instead of an enclosed pouch, the male carries the eggs externally, attached to a specialized brood patch beneath the tail. Here, dozens to hundreds of eggs are fixed in place, exposed directly to the surrounding water. But they are not entirely unprotected. Each egg is embedded in a vascularized region of the skin, connected to blood-rich tissue beneath. Oxygen can diffuse from the father into the developing embryos, and waste products can be carried away in return. It is a form of support, but not control. There is no sealed boundary, no buffering against the environment. Temperature, salinity, and external conditions still act directly on the eggs. Once again, the strategy sits between extremes, not fully exposed, but not fully protected. For a strategy built on invisibility, the environment is not just a backdrop. It is everything. The leafy sea dragon is found only along the southern coasts of Australia, inhabiting temperate reefs, seagrass meadows, and, most importantly, dense kelp forests. Here, structure is constant, but form is not. Kelp does not grow as a rigid framework. It shifts, bends, and reforms with every movement of the water. Light filters unevenly through its fronds. Shadows fragment and reassemble. Visibility is never stable. It is within this instability that the sea dragon strategy works. Its body does not match a single plant or even a single shape. This flexibility is essential because kelp forests are not uniform environments. Different species grow at different heights, densities, and orientations. Light conditions vary with depth and time of day. By avoiding a precise mimicry of any one form, the leafy sea dragon remains effective across a range of microhabitats within the same broader ecosystem. Instead, it mirrors the variability of the environment itself, its drifting motion, its broken outlines, its constant change. But this dependence comes with limits. The leafy sea dragon is not a strong swimmer. It does not migrate over long distances, nor can it easily relocate if conditions change. Individuals often remain within relatively small home ranges, tied to specific patches of reef or kelp. Remove that structure and the illusion fails. Without dense vegetation to break up its outline, the sea dragon becomes visible. Without the constant motion of the water, its slow drifting becomes conspicuous. And without the surrounding ecosystem, the small crustaceans it feeds on become scarce. These systems are also interconnected. The same vegetation that provides cover supports the small invertebrates the sea dragon feeds on. As complexity is lost, it is not just visibility that changes, but the entire structure of the food web. What begins as habitat degradation becomes a cascade of effects, each reinforcing the next. This is not an animal that can adapt quickly to a changing environment. It is an animal that depends on one. And when an animal depends so completely on its environment, any change to that environment is no longer a challenge, it is a threat. For the leafy sea dragon, that threat is not a single dramatic event, but a series of gradual shifts, punctuated, at times, by sudden collapse. Across southern Australia, the kelp forests and seagrass meadows these animals depend on are in decline. In some regions, the change has been profound. Over the past half century, up to 95% of giant kelp forests have disappeared, reduced from dense underwater canopies to scattered remnants. And this loss is not always slow. In 2011, a marine heatwave off the western coast of Australia drove water temperatures far beyond their usual range. Kelp forests that had persisted for centuries were wiped out in a matter of months, replaced by simpler systems that have, in many areas, failed to recover. Events like this do not just reduce habitat, they transform it. In many cases, the ecosystems that replace kelp forests are simpler and less structurally complex, dominated by turf algae or sparse vegetation. These environments do not provide the same level of cover, nor do they support the same diversity of small prey species. Even if life persists, it is not the same system the leafy sea dragon evolved within. Even outside of such extremes, the pressure is constant. Warming seas, pollution, and coastal development continue to alter the structure of these ecosystems, thinning the vegetation and simplifying the environments that once provided cover. For a species with limited mobility, these changes are difficult to escape. The leafy sea dragon cannot simply relocate. It does not travel far, and suitable habitats are patchy even within its already restricted range. When a population is lost, it may not be replaced. There are additional pressures. The aquarium trade has historically relied on wild-caught individuals, and although collection is now tightly regulated, the species has proven difficult to breed consistently in captivity. Replacement is not straightforward, but the greatest vulnerability lies in the same trait that defines it, its reliance on remaining unseen. Camouflage is only effective within the right context. Remove the kelp, simplify the environment, or change the movement of the water, and the illusion begins to fail. What was once indistinguishable becomes visible, and for an animal that has given up speed, strength, and protection in favor of invisibility, exposure is not a minor disadvantage. It is a fundamental risk. The leafy sea dragon is not simply an unusual fish. It is an example of how far a single strategy can be taken. Every aspect of its biology, its shape, its movement, even its reproduction, has been shaped by the need to remain unseen. But specialization has its limits. When survival depends so completely on a specific environment, change is not something to adapt to, it is something to withstand. And not all species can. I hope you enjoyed this journey into the leafy sea dragons. If you're interested in the research behind this episode, you can find a document with image credits and sources in the description below. These videos take a great deal of time and research to produce. They will always remain free to watch. But if you would like to support the channel and gain access to new videos a little earlier, you can find a link to my Patreon below as well. If this video sparked your curiosity, don't let it stop here. Share it, talk about it, and keep learning. There's still so much to discover about the world's rare and remarkable species. And the more we understand, the better our chances of protecting them. Thanks for watching.